looking forward to the next session, which is the Actuarial Society of SA Climate Index. Quite keen to hear on the speakers. If I can welcome them on the stage, Rendani Mbuva, Nadine van der Walt, and Willem Lenman. Thank you. I don't know if you know if Willem is making. Oh, okay. So I'll hand over to you guys. Thanks.
Thanks so much, Ricardo. Let's give a moment for people coming in. Yeah, so apologies for Professor Landman. He's a meteorologist who decided to stay in Pretoria for the day, but a lot of his contribution, which was valuable for this, in terms of rationalizing it and becoming the product that it is, a lot of his wisdom went into it. So we really thank Professor Landman for that. So I'll go into then the climate index. It is, if some of you have joined our launch event online, there'll be quite a lot of familiar stuff, but we tried to, put a bit of a season finale in some of the content that we've added. So we're gonna start by just chatting a little bit about, why do we develop the climate index? What have other jurisdictions done in terms of, actuarial professions embedding an understanding of climate variability and what the different associations have put in. We'll talk about what we've worked on in terms of the ASA Climate Index. We'll do a bit of a demo. Again, some addition to what we've shown before. And we'll talk a little bit about some of the use cases for the index and then some interesting analysis we've done since the launch. We'll talk again about how notable past climatic events have been represented in the index. And lastly, we'll talk about the future developments of the index and different directions, both from a research curiosity point of view, but also from a practical use case for the profession and the industry. So, I guess to say, this is a graph that you probably see almost everywhere, and this is not a projection. So this is not going all the way to the year 2100 and saying that everything is heating up. But this is really an ongoing trend, particularly from what are called reanalysis models made by different meteorological agencies around the world. And the idea of a reanalysis model is you assimilate observations into what usually what your medium range forecasting model does, which is what your weather model over the period of 10 days does. And then what this do is they try then to use that to interpolate over bigger areas in space what different trends shows. And this is again arising, it's not a projection as I've said, it's observed data over increasing temperatures in time. And the question for us really is, what does this mean from a risk perspective? And the principle that we sort of take as we develop the index is we data people, right? We understand the data, we like analyzing it and translating it into decisions. And so we don't necessarily debate, what is called, the attribution and detection problem in climate change, but particularly then once we notice a trend, we then look at what sort of, how it affects risk measurement and risk management. So given the increasing trends in observed temperature, there's been interesting analysis on how this then plays out, particularly over Africa. And this is where a lot of research in terms of climate projections comes in. And what then happens is you take the observed data that we've seen in the previous slide, and then you sort of run into different scenarios. A scenario that most countries agreed to, which I think we are now agreeing that we're now missing, is that we're accepting 1.5 degree warming by the end of the century relative to pre-industrial levels. That's really the scenario which is on the dotted line across, and that means a little bit of things at at different levels of confidence. And this is an outcome of analysis done by the Intergovernmental Panel on Climate Change, which analyzes a lot of climate analysis being done around the world, and then synthesizes the evidence in terms of what the potential different events will play out. And particularly for Africa, perhaps of interest to us is the middle column that talks to as the warming levels increase above these pre-industrial levels, you start seeing again some impacts on health-related and morbidity-related effects. You start seeing sort of food security risks also increasing in that end. And if you look on the graph on the right, you also start seeing again in terms of the blocks there, what are called IPCC regions. They try to analyze the evidence across different sort of cross-sections in space or in terms of different jurisdictions. And what we see, perhaps from the evidence of the projections that are coming out, is that there'll be potentially an increase. And again, it is a function of, the color is a function of how strong the evidence is, because these are different scenarios, and depending on what the different calibrations or different models become, you have different levels of evidence. But some of the increasing sort of hazards that we're going to see in our regions, which is almost like South or East and Southwest Africa, is things like wildfires, extreme rainfall, and a bit of both. And as you see with climate change, is that you see both ends of the spectrum, but with more extremes and frequency of such events. So in the event that you get reports from the IPCC suggesting the results that we've seen in the previous slide, it's important that we, as a profession in South Africa, come up with a common, basis for measuring this in terms of, are we seeing this in the data that is observed over us? And if we're seeing this, how do we express it in a way that, somebody at a different, at a different insurer or reinsurer can then correlate that with the experience. And this is really at the heart of what we set out to do in terms of, coming up with a set of metrics that in a way try to cover some of the areas of interest in terms of climate variability as it affects the risks that different insurers underwrite. And again, it can also be used as a policy tool broader than the society. The interesting discussions I had earlier today where SASRI is considering aggregating some of those risks. You've seen different risk aggregators coming in. There are also different things that you could think about from a risk aggregation point of view as well. In terms of Africa risk capacity and different things where South Africa does not necessarily participate sometimes, but we will see how, if we can then track the frequency of such events, how these sort of data sets can actually help. And again, this standardizes a lot of the data that is assimilated from meteorological services, as I've said, depending on the data sets that we've used, and Nadine will elaborate on that. So we'll quickly move on to a bit more global context in terms of what the different activities in terms of climate indices around the world has looked like, and a bit of a demo of our work as well. Nadine, take it away.
Good afternoon, everyone. So I'm just quickly going to start off with just acknowledging some of the existing climate indices that are already accepted around the world. It's really amazing groundworking work that these professional bodies have done and that we've also drawn inspiration from. I'm not going to go through them in too much detail, but I think it's important to just acknowledge the existing basis of work that we've also used as a basis for our understanding and development of the index. So the first, and I think one of the most more well-known climate indices around the world is the one from the Actuary's Climate Index from the USA and Canada. Then there's also the European Extreme Events Climate Index, or the E3CI, the Australian Actuary's Climate Index, pardon me. So they've actually launched their second version of the index now in October, which is very exciting. And this also, I think, underscores what we have envisioned for the ASA Climate Index, is that what we have now, what we've built now here, is just sort of the stepping stone for what's to come ahead. We already have a very good basis to work from, but this is not intended to be the one and only version. We will continue working on it, updating it, adding to it, adding more components as time goes on, even though this is already, I think, a very good basis to start off from working. And in that line as well, what the USA and Canada, with the Actuaries Climate Index from the USA have also done is they released a climate risk index, which then specifically takes the climate index, but then makes the link to damages, which is, of course, I think the end goal here for us as actuaries to actually make that link. And we are also going to hint at that in one of the use cases that we're showing today. Okay, so then moving on to what we did for the ASA Climate Index. For this version, we are focusing on 4 major components, as well as an aggregation of them, with the intention of adding more components as we go along. So the basis of these components are temperature and precipitation. We've got heat stress, cold stress, extreme precipitation, and drought. So we primarily use 2 data sources for this. AG Era 5 is used for temperature and precipitation, and then CHIRPS is an alternative for precipitation. The reason why we do this is because there is no universally accepted and best precipitation data set historically for South Africa. There's no data set that is the best over all regions and all time periods. And for example, also, if you look at trends versus extremes, then data sets perform differently as well. So that's why it's important to also understand these data sets. And we do have quite a comprehensive literature study in our technical documentation, which is available to the public as well. So these data sets are gridded, essentially. So we dividing the map, or you can think of South Africa up as like in blocks. AG Era 5 is 11 kilometers and CHIRPS 4 kilometers, more or less. And this is complete daily data from 1981, and it's very recent. It gets updated very often, so we can, and it's also reliably used across the globe. So we know these are reliable data sets that will continue to be available going forward, and that we're able to update the climate index. So every grid block is then determined, or let's say modeled separately. So for every grid block on the map, we essentially have a time series. And for every grid block, then we have a climate index value as a time series going forward, which we then combine on a map for South Africa. I'll show you some visuals just now, and then we can aggregate that to different regions, for example, districts or provinces. So how you can think of the climate index is that we're trying to measure when do we have unusual occurrences of weather phenomena. This is the crux of what we're trying to represent here. And that we are expressing in terms of exceedances per month. So we're looking at the number of, or the frequency of unusual weather occurrences in a month, and then that's expressed as a time series. So I'm not going to go into too much detail on the technical bits. I don't think that would probably be followed very well, but there, like I said before, there is technical documentation available. Just as an example, I'm just taking the precipitation component. So every day, every calendar day in the year, then will have its own test sort of threshold, where we want to say, okay, if the observation exceeds this threshold, then it's extreme. So it's basically a test, yes or no. Do we have an extreme occurrence on a day or not? So that threshold is determined by looking at a 31-day window centered on your reference day. So let's say we're taking January 16, then we're looking at January 1 to January 31. We're taking the 30 years of our base period. Our base period is 1991 to 2020. And then we look at the 95th percentile of those days. So it's, don't worry if you didn't follow all of this. It's, I don't expect you to. I think the point is, just every day has its own threshold. We test, does it exceed it, yes or no? Then the second part is now it's actually becoming quite simple. You count the number of exceedances in a month. So one month might have 5 out of 35 exceedances, and then we standardize that according to the mean and standard deviation in our base period. So the idea here is over all components to have something that's comparable to one another. Because what you interpret in precipitation, you want to be able to sort of relate that to what you see in temperature, the same scale. That's why we count frequencies and also why we standardize. Okay, so now I think for the fun part is the demo. We did put in a lot of effort, I think, to try and make this user-friendly and consumable to the public and to the professional community. So this is publicly available. Anyone can go there, anyone can play around. You can visualize the data, because I think also with maps and spatial data, it's difficult to visualize it. It's not like an Excel spreadsheet that we're used to. You have to really see it in the spatial context. And for that, you do need visuals. So you can see when you go onto the website, you can see this nice map. It starts off with the latest data from precipitation. And if you click on the map, then it takes you to an interactive window. It essentially takes you to this index page. You can see what's happening. There's some filters if you want to change the data set, the time period, the component. You can maybe click on Gauteng. It wasn't that eventful in August, but we have something here in Sedibeng. So you can see then it zooms in, then now you have a district view. And you can click on Sedibeng, and then you have a grid view. So one of the things that we're also considering adding in the future is just a bit of a base map to look at, then you can see where are the cities, so you can just orient yourself a little bit better. And then, but now, let's say you want to go into a bit more detail, because you can slice and dice this data in a lot of different ways. So let's go, for example, I don't know if any of you remember the Vaal Dam and all the havoc that the sluices caused earlier this year. So we can maybe just have a look there. So let's go to April. It does look quite blue. I usually like to look at it in a grid view because it just gives you that spatial granularity. So you can actually see here the rainfall, and that's why the sluices had to be opened. And like I said before as well, we have 2 different data sources for precipitation. There's actually a lot of ways you might, and a lot of reasons you might want to do a comparison, but I think this is nice because then you can see 2 maps next to one another if you go to this comparison mode. So let's also go to precipitation here and do a grid view. And then we look at the same month, but now we just use a different data source. And then you can see the differences. So I think it's quite nice to be able to play around, especially if you want to understand something quickly. There's a page here for data downloads. So you can download the data in CSV. You can choose, do you want it aggregated nationally, provincially, or on a district level? What component do you want? How do you want it aggregated in terms of, temporally? Do you want a seasonal aggregation, annual, 5 years, monthly? How do you want to represent your time series? And then start and end, and then of course your data set. And then, as I mentioned before, we've got some technical documentation, so those who want to just understand a bit more, then there's some interpretation, and then of course the technical documentation that's just free to download. Anyone can then go have a look at that. And so with that, I'm going to move over to just a bit of a use case, because I think this is very nifty, it's very cool. A lot of flexibility here, but I think the question remains, like, how can this make sense in a business environment? How can we use it as actuaries? So I think it does have quite a lot of uses, and depending on the context, I think you can use it in a lot of different ways. specifically banks and insurers. I'm sure other, that's more my sort of fields that I'm more involved with, but I'm sure like retirement matters and investments and so on. Anything really where you have a time series and you want to see, okay, but how does climate risk correlate with my time series, whatever it may be. So for this case study, I actually looked at growth rates, so residential real estate growth rates. The reason I did that was to look at, is because that would then affect loan to values for a bank, for example, for retail real estate, residential real estate, which can then be linked to LGDs. Because this link from credit risk to climate risk is very important. And I think that's something that's really missing in the industry, and that the regulator, I think, is also sort of trying to encourage practitioners to try and do, is to make this link between their credit risk parameters and their and climate risk, and to really quantify it. Okay, so this is just a very quick case study, just to sort of illustrate how this could possibly work. So I looked at KwaZulu-Natal specifically, and looked at what did the climate index do over the different districts. So because residential real estate is not, it's not something that you won't immediately see the effect. That's why I took a rolling 36-month average of the climate index, because it's then gives you an idea of persistent events, persistent occurrences of extreme events. And it also has a bit of a lagging component. So I defined the a climate stress period as whenever this rolling average exceeds 0.3, and then regressed that against property growth rates. So the growth rates were rolled up to district level. I excluded areas where there are no or negligible flood risk. The reason for that is I don't want to mix areas where I expect no effect with areas where I expect some effect. And the results were actually very interesting. There was a notable difference in the growth rates during periods of prolonged climate stress and not stress, and that I was actually able to quantify the difference in the growth rates. And just a side note, I also just corrected for general trends by looking at what national house prices have been doing, just to make sure that that effect is not confounded or confusing the results. So of course I think a lot of extra work can be done on a case study like this, but it just illustrates how this can actually be used to get a quantification. And just to also underpin the results, just make sure that what are we seeing here? Is it actually climate risk? So then I looked at the different districts, attached some flood risk to that, and compared the house prices, the average house price market value from 2022 April to 2025 January. And there was actually a notable difference in the average, in the change in average house price between the two different time periods. So on the graph there, you can see the first few lines are where we have no risk or low flood risk, and there was a positive, difference in the average house prices. But when you get to the higher flood risk, you actually see a decrease in average house price risk, except here in Ugu, where there was a bit of a data anomaly, where there were few data points, and then, so that's what that increase was about. But you can generally see climate risk did have an effect on house prices, and from the previous slide, we are able to quantify this based on the climate index. Okay, and with that, I'll go over to you, Danny.
Yeah, so I guess some of the analysis that we then do is to say, again, what does this mean from an insurance risk perspective, is to say, well, again, looking at some of the CAT experiences and some of the, flooding events that are fairly notable in the country, how are they represented in the index? And this is really what the other sort of test that we do. I tried as part of trying to get some data to sort of validate our index, and a lot of the friendships that I have in the industry actually didn't work. So I ended up having to look at annual financial reports where cat losses were reported or any other publicly available information. And one of the interesting cases was looking at data that was reported by Santam, as well as data that was reported by Old Mutual Insure. And again, for us was to actually then look at the two sort of peaks, particularly as they relate to the Knysna fires of around 2017, and also when you start looking at the KZN floods more recently in 2022. And we wanted to see again, how the evolution and the values of the index nationally actually look like as it compared to those cat loss events. And what we see predominantly again is we see that they are correlated to elevated levels of the index, particularly as you look at particularly the extreme rainfall index in this particular case. As you start sort of comparing it to again this are inflation normalized total losses in this case for both books. And what you see there is, elevated in terms of, the precipitation component, and also a little bit where flood risk was also relatively elevated in one book. But then you see quite a bit of you'll see in the next slide why fire was more elevated on the Old Mutual Insure book relative to the Santam one. But the correlation levels in this case looked really interesting in terms of how this were correlated. And then again, as you look at, for example, the KZN floods in 2022, you can actually see this is what the index looked like in that time period, particularly as you look at precipitation, and you almost see almost its highest value yet at that point in time when those floods happened. Again, if you look at what we also found what was interesting was when you started looking at the correlation between our drought component of the index, which looked at prolonged periods of dry days, and what that naturally yields is what are called wildfire leading conditions, and what we found very strong correlations between that component and wildfire events. In terms of when it peaked and actually when you saw, for example, the Santam data in the annual report was segmented by different hazards, so you could actually tell how much of that was caused by fire and how well that correlated. And then again, you could see a big effect also on the OMI book as well in terms of that. And again, this is really now looking at the drought component of the index. One slide back. Again, this is what the drought component of the index looked like at the time of the Knysna fires. And again, you see the Overberg region when the fires happened was fairly elevated at that point in time. And again, when you sort of look at the component, it's almost at peak levels at that time of those events. So I guess what this shows is, this was the value of the index. This happened, right? But I'm assuming, within a technical office, the question is, what will be the value of the index and what will happen? And next step that we're spending quite a lot of time to do is actually looking at forecasts of the index to say, what does it look like in the next 3 months? What does it look like in the next time period? So what we're investigating for this, and this is actually work that one of my PhD students at the University of Manchester, who just arrived in September, I threw the problem to her and said, we've built this thing, can we look at different ways to forecast it? And one of the ways that we're looking at is this long short-term memory networks. And the idea is that in climate data, there's often what are climatic regimes, which are sometimes formed by sort of what we call mode variability. There's like the Indian Ocean dipole, which sort of swings from this end to the other. There's the El Niño, La Niña cycle in the Enzo region. So you want to keep a lot of memory in terms of how you focus that. And this long short-term memory networks are really good at that, but they have some problems. And what we're investigating now is an extended version of that that looks into addressing some of the problems that they have, like well, from a machine learning perspective, what they call vanishing gradients. They don't fit well if you've got too much data and it doesn't change a lot. And we experimenting using this extended LSTM models. And what we've seen is that while trying to look at a 1 month ahead projection, the fit looks relatively well, but we really want to stretch the lead time to which we want to do that in terms of, this on the left you've got the precipitation, and then on the left you get precipitation, on the right you get temperature. And this is a model that we've trained with all the data up until 2015. And we're testing it. This is the testing period, from 2016 to date. And we're trying then to look at, how do we sort of fit it with 1 month behind? What does it look in the next month? And this is sort of like the simulation of that process. And what we see is, relatively good goodness of fit scores in the model. But again, this is work in progress in the sense that we want to push the extent at which we can run those projections such that we have sufficient what I would call actionable intelligence in terms of where things would come. So, but then the different lines there, just the dotted lines are often what the model is saying, and then the darker lines are the observed data in the testing period from 2016 to date. And then the little red dot is just telling us what the September value would look like, because we use data up until August, so we'll know whether we're wrong or right there. But this is work that's actively in progress. I guess, in terms of what's next for the index, is we're looking at, of course, when this work started, somebody, I actually mentioned them by name because we're working very closely with them as chair of the committee. Ron Richmond said to me, we need to understand hail a bit better. And the sort of, meteorological advice that we got on hail was that it's very difficult to measure and model hail because it's a fairly local phenomena. But you can start looking at what is called hail leading conditions as well. So there's often symptomatic of vertical movements of air and the different parameters that we're investigating for that. But it will be packaged for the profession as an index component. But what that means is that you rather than model a specific hail event, you model the high likelihood of having what they call significant hail, which talks to the size of the hail block that comes down. So that's something that we're looking at investigating for next. When we started, we wanted the different wildfire indices. The drought component is working really well, but we could make something bespoke for wildfires as well. And again, we're looking at different ways of aggregating the index. One of them, for example, is we take the composite index for the country it's a spatially weighted average, which means that from an economic exposure point of view, something like the Northern Cape is overrepresented. And then can we do like night light intensity, sort of like weightings, which, in our case, not anymore, would not be a representation of load shedding, but would correlate to economic activity. So that's something that, in terms of how you weight it, but again, for different books of business, the weighting of the index could be different, right? Because that's really where your exposure is. And then I guess, focused in the index, we started there. And then again, for reporting purposes, you need to then look at this in a multi-decadal scale, which is what the climate projections tell you. If you've got a 30-year mortgage or a 20-year mortgage, what does this look like in 20 years? Predominantly once you found a link to your risks and your losses. So these are some of the areas where we're looking to take the index to. But we're very happy to take questions. And again, we're grateful to the Climate Change Committee at ASA, and the ASA team overall who supported us in sort of developing this for the profession. Thank you very much.
We do have microphones moving around, just checking if we have any questions from the audience. Here we go, we've got a question there. We're going to get a microphone to you.
He made me promise I won't ask any question. Sorry. Can you share? Well done on this. I think it's fantastic that we can make this kind of contribution. How can policymakers make use of this tool?
Okay, my microphone. microphone is on. I was hoping it was off. Okay. So look, I think there's two things, right? So I think it's one way to. I was chatting to a policymaker a few months ago, and they were pretty concerned about KZN. And they're like, we're seeing this happening in different areas. What does this say about where people settle? And again, that special understanding of where this variability is happening. Are the areas where, from a policy perspective, should be condemned from investing in property in different areas? So data like this allows evidence-based policy that you'd like to see. And I think also, particularly, the UN and different agencies are talking about this early warnings for all initiatives where they estimate large numbers, millions of dollars in terms of, if you can warn, life and property about impending climate events, you save quite a bit financially. So again, that the data supports, building an evidence for different policies, both, from a climate negotiation perspective, to deciding how different municipalities assign different regions for residences.
Any other question?
Yeah, thanks, Arendani, for that. I'm just trying to think of this from a global perspective. So you guys shared some indices around the world. What are the sort of actions that you see at a global scale, maybe in terms of the similar question that the President asked here, given some of the climate skepticism overseas? Thank you.
Okay, I see this is working. I think the most notable action from my side that I've seen was the climate change or the climate risk index that the Northern American Society of Actuaries has developed. And I've also seen some research that the Australian Actuarial Society has also done on linking the climate index, the signals, the data to actual damages. I think that's such an important step. And just to add to the previous question as well, I think that that's maybe some common ground where industry can collaborate with policyholders, because I think to really tackle this in a responsible way, we need data. And this is, I think, the first step in getting the climate side of the data. But then if we, in some way, can collaborate between industry and policymakers to translate that, but what does it mean for risk? I think that would make a very well-informed path to better risk management for the industry.
Okay, we've got a question right at the back. We're going to try and get a mic over to you. Okay, we've got one there and one over there, because it's...
You can go for it.
Oh.
Yes.
Oh, thanks. Just a three-part question.
I love those.
In the interest of time. So the first question I have is, will you please clarify the baseline that this index uses? As time goes, does the baseline also change? That's the first question.
Should we try that now? So what the WMO recommends, which is the World Meteorological Organization, they always say, and this is baseline of most climate measurements that are happening. They always say that you use the latest complete 30-year period as baseline, and they keep on sort of like sliding a window around that. So the current window, which is sort of like endorsed by the WMO, is the period 91 to 2020. So that's the baseline. So all our values expressed as relativities to the frequencies, as Nadine mentioned, observed on average in that period. So then we're saying, well, relative to that baseline period, this is what the index values look like.
Okay, and just to clarify, this baseline, is it like a normalized baseline, or is it including the peaks and troughs of the normal?
Yeah, so So the baseline we use to derive the normals, right? So to say, well, if this is a frequency of, for example, in temperature, we talk about, hot day frequency or hot spells. So this is the frequency of hot spells in this period. On average, it's X. And then in this particular location. So then we say, once we observe, we derive those normals in that baseline period, and then we express everything based to the normals. In this case, those are just the standardizing parameters for the index.
Okay, cool. Thanks. The other two questions on the projection aspect of this, right? So, what would inform like the inputs in projections? I just want to understand mechanically how that would work and whether you'll be able to selectively project a specific component of the index that you want to model or include in your modeling.
Okay, cool. Yeah, so the projection aspect interacts between, again, this sort of work is quite multidisciplinary. So there are, I would say, about 15 modeling groups around the world that run what is called global circulation models. And the idea of the global circulation models is that they simulate different variables, temperatures, and other things. And these are dynamical models. So they're physical models that look at Navier-Stokes equations for the physics to say what happens in different warming scenarios over the next, up until 2100. And there's what is called the climate intercomparison project. So they sort of push their data into one space. And then you have different projections from different models that are parameterized differently. So what the projection piece of this work would do is look at, again, some diversity in those projections coming out of this global... CSR used to be one. I'm not sure whether they're running their models now, but you'd have the different projection models inputs coming in. You then sort of calibrate the index onto those, and then you can tell what the different scenarios look like, in a few decadal times. But those are scenarios based on, the sort of radiation sort of retention in the planet. Temperature changes over time.
Sorry. Hi, thanks. Ed Stoddard here with the Daily Maverick. I just want to double check something. The index is live, I see. I was just wondering when it launched, when did it go live? And I was just wondering if you've had any feedback from users. And also just double check, beyond the baseline, how far does the index go back? Is it 2001, is that correct? Or,
so just to the first question, the index launched officially on the 23rd of September this year. We did get some feedback from users. We didn't get quite a lot, but we did get some feedback and some interesting observations that people made. We also, before the launch, distributed it to some of the committees at ASA, where we already pre-launch had some very valuable feedback as well. And then just on how far back the index goes. So the data sources that we use go back to 1981. So the index is available as from 1981, even though that is before our base period. But because the data is available, then we make that available as part of the index as well.
There was a question on this side earlier. I see two.
Cool.
Maybe one mic can go to the back.
Yeah, I mean, firstly, definitely want to echo the gratitude for this resource. I think it's fantastic. I was interested to know what the thoughts were on the use cases for this composite component, the one which averages across the different, the precipitation and temperature. Just because I'm curious if there's any specific use cases that metric is particularly interesting to analyze.
To be honest, we really included it because it's sort of the standard globally that the societies release a composite index. But from my personal opinion, I would rather look at individual components. I think it's a lot more useful, especially because, when looking at a use case, you will very much likely be interested in one specific component and its application. So I would actually encourage rather looking at the individual components. I think sometimes there might be some cases where it might be useful to have a composite. It's there if a user wants to test it, but my first go-to would be to look at the individuals.
Yeah, so we had the same question just to add, and Nadine and I investigated a few cases where the composite eventually just becomes zero because the temperatures and the rainfall cancel out perfectly with some freak accident. So again, the different components are more reliable.
Hello. Oh, sorry. Thanks. I think maybe just one clarifying question first. So in that, when you shared the world indices, South Africa doesn't seem to have another climate index. So would this be the first for South Africa?
So I think officially, as endorsed by our professional body, but I know there has been some research going on alternative ways to calculate. I know of a research paper that has been submitted to ASA's Actuarial journal that also introduces a climate index, but I'm not sure if that's already been published.
Okay. I guess curious in terms of how, if there are multiple, kind of how it compares, but I guess we don't have that information yet. Maybe just a comment. So climate change and this index is probably valuable for all of the industry and not just actuaries or people in risk management. Have other industry bodies, are they aware of the index? Have you shared insights on the index? Do they understand how to use it? Is there collaboration with those industries to understand how we can make this index usable for them as well?
Yeah, I think we're really starting out in terms of dissemination of the index work. I mean, I think one of the interesting events we got invited to more recently, I think it's happening on Friday, was actually meeting municipalities in the country. And the different municipalities are coming together and they wanted to hear about the index. Very interested in the sort of discussions that emerge from that. And as a function of that, there's some discussions about, parametric insurance and sort of risk aggregation to some extent. Well, this is just the talks that were lined up for the function. So I think there's still probably lots of room to go in terms of dissemination and interacting with different groups.
Great, thanks. And congratulations on the launch of the index.
Thanks. Speaking of Santam, they just got a license to sell parametric insurance. Do you see a use case for the index within parametric insurance setting?
Yeah, I think so. And I think actually because the big debate in parametric insurance is the basis risk, right? So it's which data sets to use because you don't want you need to really know whether they drained or not. And already what you saw with CHEPS and AGR5 is that, depending on whether the basis for the product is CHEPS or AGR5, someone will get paid, someone will not get paid at the same location. But I think that's probably room for us to investigate, this different sort of data products because probably notwithstanding the effect you install a weather station at every client, it's probably going to be a gridded data product. And I think this is the expressions of different things for a product will look differently, but I think it sort of might be an easy way to sort of come up with, common definitions of different sort of product definitions.
Just to add to that, I think also this is where, claims data and actual loss data becomes really important because you might have an area where yes, there was a lot of rain, but it's not necessarily at risk of, a peril that's very costly. So then there's that sort of interplay as well, whereas a location that's, let's say, next to a river, that might have a lot of, losses associated with it. But so that link between the extreme occurrence and the actual loss still needs some additional data.
Any other questions? Not at the moment. Or okay, I think we're going to close the Q&A section for this one.
Yes. Thank you for the insightful session and congratulations on the index. I certainly am looking forward to playing around with it and seeing what we can do in our area. And thanks to the delegates for attending.
Great, thank you.